Hi everyone, welcome back to my math teaching again. So in this video, I am continuing with the trigonometric function, but the last section of it in our chapter 6 of the course Introduction to Calculus. So in this video, I will talk about the inverse of trigonometric function and the derivative of it, right? So on the bar, I already have their formula right here. So I will upload this document to our course online, and you can just download and have it, right? So let's look at what are they. So I have on the left, I have a f of x, the same like con y function, right? On the right hand side, I call a f prime of x, which is the derivative of y function. So let's say I have a derivative of y equals sine minus 1 on the top of x, which is inverse of x, right? And you know that on your calculator, if you have a sine function, let's say you key in sine 3/4, and then in your calculator, you hit sine minus 1, which is the inverse of it, then you get this angle is what? So if you hit 3/4, it's the same like 0.75, right? So let's see what is the angle supposed to be. So let's do sine minus 1 of 0.75. Gotta be in radian, right? Yeah. So this angle is, okay, let me check the mode a bit. Yeah, in radian. Okay. So in radian, this angle is theta equal 0.84. And we can draw up becomes 0.85 radian, right? I'm talking about the radian, okay? So this number is the angle of theta instead of in degree, but it in radians. So now you understand what the inverse means, right? So if you have a function, the ratio of psi, and the inverse of psi is the angle, right? The inverse of psi is the angle. So what does that mean? Now, in notation, you have let's say you have a function y equal the inverse of psi. You also can write this function at arc psi x, like that, right? And if you have a function equal the inverse of the cos, then you can write as the arc cos x as well. So arc cos x, arc psi x, y equal inverse of 10, you can write it that as 10x. So this notation is just the same one we're talking about. Okay, so this equal this, this equal this. You also have an inverse of secant x. And you know that secant is the inverse of the angle, so that's why it's the same like cos, the inverse of cos, but instead of x, it would be 1/x, right? And the inverse of cosecant, so instead of like inverse of psi, will be inverse of psi, but the angle is 1/x, because you know the inverse of psi is a cosecant, 1/psi, right? So therefore the angle is inverse like that as well, okay? So now let's see what is the derivative. So if you want to take derivative of the inverse of sine or arc sine x, the answer here, 1/square root of 1 minus x squared. the inverse of cos x, or the function as cos x, the answer for derivative exactly the same like the sine, except that you have a negative fraction. So for us sine x is the positive fraction. So the inverse of cos x is the negative fraction. So they are exactly the same, but one is positive and one is negative. Now the inverse of tan x, the derivative of the inverse of tan x is 1 over 1 adding with x squared. So you will examine this formula from your course. Okay, so now I would like to go into the details a little bit. I will show you. Now you will say, oh, where did this formula come from, right? You want to know, how can we know that the derivative of the inverse of sine x is 1 over square root 1 minus x squared? How do we know that? So I'm going to show you and prove it to you, right? Okay. So let's talking about the first one. So we have y equals sine x. But remember, now we want to talk about the inverse of this function, right? It's not this function, but the inverse of this function. So the inverse of this function will be x equals sine of y. You know that like inverse, it means you interchange the coordinate, right? If the coordinate is x and y, x comma y, the inverse will become y x, right? So this is similar idea. So y equals sine of x, its inverse will be x equals sine of y, right? Now sine of y here is the same like sine of y here, the same like sine of minus 1 x, right? So this is the angle, so this is the angle, okay, the inverse, because remember the inverse is the angle, right? When you key in, the inverse is the angle theta, right? So now let's draw a quick triangle. So ugly. So let's draw a triangle. Now this angle is the angle theta, right? Which is the same like sine minus 1 on top, right? This is the angle. Remember, this notation is the angle, right? So now we look at the inverse function here, right? This is the inverse, right? Inverse. So this angle the same like angle y actually, right? Angle y. And it say angle y equal opposite over hypotenuse, right? Sine of the angle y equal opposite over hypotenuse, right? We can put 1 underneath. And this is the opposite of the angle, right? So we put an x in here. And 1 is a hypotenuse. So what is the length of this adjacent side? The length of this adjacent is 1 square minus x square. And 1 square is just the same like 1, right? Okay. So now we would say that we're going to say that we will take derivative of this inverse function, right? Let's say this is inverse function, x equals sine y. So what is the derivative of it? You can say d over dx equal cos, right? Derivative of this is cos y and d over dy. Or you can write like derivative of x is just 1. We can do that as well. Equal derivative sine y is cos of y prime. Remember the short notation I showed you before, right? Like that. So now I'm going to solve for y prime because this is, we're going to solve for derivative, right? Derivative of this inverse function. Remember, this is the inverse function. Inverse, right? So y prime will be obviously equal 1 divided by cos of y. But what is 1 divided by cos of y? Let's look at the triangle. Cos of y, this is the y or sine minus x, right? Sine minus 1 on x on sine minus 1 on top and x, right? Or inverse of x, right? So cos of y of this angle y is this one over hypotenuse. And over 1, you don't have to write. So it's like this. So now is proving the derivative of this function, right, of this is this one, which is right here. See that? So that's how I prove it to you, why the formula came from. You get the formula here, right? Okay, so I'm going to do 2 more. Let's do the cos and tan, and you will see it exactly just like that, right? Okay, so let me engrave this. Now let's do the cos one. So I'm going to do the cos 1, number 2, which is cos minus 1 on top x. Or I'm going to say this is like x cos x, right? But to get this, we will take the derivative, we will take inverse, right? The original function is y equal cos x. This is no inverse, right? But when it becomes inverse, you interchange between x and y. So this y become x, and this x become y. Basically, this is the inverse of cos of x, right? This is the inverse function. So now we will say, okay, so this, put a 1 underneath again. So cos of y, which is this angle y, right? Cos of y equals x adjacent over hypotenuse. So at this time, hypotenuse still 1, adjacent is down here, x. So it means the sine is 1 square minus x squared by the Pythagorean theorem, right? So now we'll take derivative of this inverse function, right? So derivative of x is 1. Derivative of cos y is minus sine y, right? Minus sine of angle y, minus sine of angle y. Also y prime, right? So now to solve for y prime will be equal, I'm going to put negative on top, right? Doesn't matter, one side for negative for a fraction. And down here is sine y. And what is the sine y? Sine of y equal opposite, which is this one, the sine over hypotenuse, right? So here minus 1 and opposite over hypotenuse, which is this number. And that's why you have the same exactly formula, but with the negative on top. And if you look at here, that's exactly correct, right? So that's how I prove it to you again. This is the derivative of the inverse function of cos of the inverse of cos x. And here on top is the inverse, derivative of the inverse is of the inverse function here is positive, exactly the same. We just did it before, okay? So for the tan, it's similar. Let me finish the tan as well. Now, the rest of it, secant and cosecant, I let you accept this formula for now. Okay, I don't have to go through this because this video will take too long, right? So I'm going to just prove you sine and cos and tans for you to see where is the formula come from at this moment. But then you have to try to remember the formula, right? When you take the derivative of this trigonometric function and apply to, now once you know where it's come from, it helps you to remember them more easily, right? I guess. Okay, so now let's do 10. So we have y equal 10x is the original function. Now the inverse of this will be x equal 10y, same thing, right? So now we're going to say 10 of this angle y equal x over 1. And 10 equal opposite over adjacent, right? 10 of this angle equal opposite. So now for 10, we have to change the side, become opposite over adjacent. So the adjacent will be 1. And therefore, the hypotenuse here will be 1 square adding with x squared. Adding, right? Not subtract, right? Okay. So now we're going to say inverse, which is the inverse angle, right? 10 minus 1, x. The same like the y, angle y in here, right? So 10 of this will be equal opposite over adjacent. So 10 minus 1 x, which is the angle, right? This is the angle y, equal opposite. 10 equal opposite over adjacent. So opposite over adjacent. Opposite over adjacent. Okay. Okay. So now let's take derivative of this function. Okay, so this is the function, right? The inverse function. X equal 10y. Derivative of this is 1. Derivative of this is secant square x. Secant square y. Y prime. So solve for derivative, y prime will be equal 1 divided by secant square y. And we know this is the reverse, right, of cos, right? Because cos of y equal 1 over, secant of y equal 1 over cos, right? The inverse of cos. So in here, we can write this is equal cos square x, right? And what is a cos square x? Cos square x. Okay, so cos square x is 1 over hypotenuse, which is this one. But you square it, so it becomes 1 over 1 plus x squared. And therefore, it proven this formula, right? So I have proved for you 3 of them. Now I'm going to leave this and this. If you still like wondering, you can ask me later. But today in this video, I only have time to show you this stuff. But you know the formula, right? So you will have a file upload, and you will use this formula when you have to do derivative of the inverse function. Now, this will not be a lot exercise about this because this is the first introduction to calculus. So I just want to introduce to you the inverse formula, and maybe there's a couple of 1 or 2 questions to find derivative inverse function, but we don't go deep into that until the second course or higher level. Okay, so I hope you enjoy my brief video, and we'll see you next. Stay tuned for next one. Give me a thumb and hit subscribe. Thank you. Bye for now.